Hello, welcome to the latest edition of NCRM's In Conversation series. This is the third NCRM special In Conversation series on AI and its impact on social science. I am Mark Elliot, Professor of Data Science at the University of Manchester and one of NCRM's co-investigators. I'm joined today by one of the key figures in UK social science, Patrick Sturgis. Patrick is currently Professor of Quantitative Social Science at LSE, and at previous roles he was himself NCRM's Director and President of the European Social Research Association. He chaired the inquiry into the failure of the 2015 UK election polls and has served as Specialist Advisor to the House of Lords Select Committee on Political Polling and Digital Media. Welcome, Patrick.
Thanks, Mark. Good to see you again.
Okay, so we're going to be talking about AI, which is obviously a hot topic at the moment, and is also a term that gets used and abused, and various people mean different things by it. So perhaps for the viewers, what will you be meaning when you're talking about AI?
Well, I guess, maybe I'll sort of start off by saying a little bit about my kind of what sort of a social scientist am I, and what's my interest in AI. I guess I'm probably a bit like you. When we were doing our training, graduate training, we certainly weren't thinking in terms of data science. Those terms weren't really around then. The kind of the influence of computer science in social science was quite minimal, and we would, the sort of analyzing rectangular data sets that were nice and clean and so on was and kind of often using drop-down menus and so on. So I'm kind of a quantitative social scientist rather than a data scientist. So just to sort of emphasize that I'm not coming into the stuff that we're going to talk about, some of the research that I'm doing, as someone with a deep background in data science, computer science, and so on. Very much more a kind of conventional quantitative social scientist. And I think you and I have talked, I think, in the past, actually, in this kind of context where we've been sort of a bit devil's advocating on either side, and I've been kind of quite skeptical about, big data and so on. I'm more of a kind of a survey person, planned research, and so that's kind of where I've positioned myself often. But I think I'm definitely much more of an optimist or a believer that this is going to be quite transformational for social science. I think that this is really going to be a step change, as the cliche goes. I think we're already seeing quite a lot of signs of how it's going to change the way that social scientists work and the sorts of questions that they can answer. And I guess that also sort of positions me on the more kind of, I'm much more interested in what these tools can do than in, I guess, the other very important angle that social scientists come from, which is what are the risks and dangers, what are the ethical sides of it. So it's not to say I'm not interested in those kinds of things at all, but I'm very much seeing these as kind of that we can build new tools for answering the questions that we're interested in social science. And that, of course, that the AI has been around for a long time, and as you say, it means different things. So I'm really talking here about large language models and the huge number and quantity of these things that are now emerging.
Yes, and I think it's always worth sort of making this point that because that has been kind of forced into public consciousness, large language models and ChatGPT in particular, that then becomes synonymous with what AI means to many people. And reality, there's a much wider set of things which we mean by AI. I was just reflecting on your comments about sort of the more traditional approach to. I of course originally came from an AI background, and that meant something very different. in the 1980s when I was doing my research, and actually getting time on computers to do AI research was limited at that point, and we had to do a lot of stuff on pen and paper and working out what algorithms would mean and so forth before we even got near a computer. So I think it's worth reflecting that this was the initial steps of AI were very, very much theoretical, rather than you've got this kind of image of AI researchers sitting in their white coats next to a humming computer, and that just wasn't the case. Yeah, okay. So, I mean, in terms of your own adoption of AI, in terms of your workflow, how's that been?
Yeah, well, I think, I mean, that's an interesting point you make there, and I know I'm aware of your kind of very long-standing interest in and work on AI, and as you said, I think now we're already at a stage where social scientists, not just people in humanities, any disciplinary area, you can approach these as tools that you can use without really needing to know very much about what's going on under the hood. I mean, that's all very interesting. So, I mean, that's computer science, right? But we can take these tools now and use them, deploy them very flexibly. And I mean, that's, I guess, some of the things that we'll talk about now, the sorts of things that how I'm using it. I guess, so the first thing I think I want to talk about would be, yes, the pipeline, the workflow that now is accessible to someone like me. And going back to my earlier comments about, I'm not someone who codes freely in Python. I've sort of had this difficult journey of learning SPSS. I was very, very proficient in writing SPSS code, and then that becomes very unfashionable, and I moved over to using Stata, and I learned how to be very good at Stata and so on. And then R comes along, and I'm kind of like, oh bloody hell, I'm going to have to learn something else now. I'm getting too old for this. So I was never really great at coding in R, and certainly not in Python. But what I've found is that with the help of ChatGPT, or other large language models are also equally good or even better at this, are what's called vibe coding in the lingo. I don't think that's the greatest name for it. I see where it comes from, but I think I prefer to think about it as kind of goal-oriented coding. That you're, because I think that's important, and you'll see. I mean, I think you know what I'm talking about, but in order to do this, it's not open to anyone, because you need to know what you're trying to do. Okay, you need to know where you're trying to get the thing that you're trying to. If you want to analyze data, or you want to build a particular kind of chart, or you want to set up some pipeline to scrape text from documents and so on, you need to know what the thing that you're producing should look like. But if you do that now through just language coding, just through telling ChatGPT what you want, it will take you through the process. It will, and I did this a little while ago. It told me to install Anaconda. It's told me to open up Jupyter notebooks, and it told me to put this code in here and run this. And sometimes it wouldn't work, and you put your error message in, and this, I mean, it's really incredible how it can take you from not really having those skills that people have toiled to develop, that you can now access this kind of functionality. And so one of the things that I'm now able to do is quite quickly, as well as a very, very quick process that you can build these things, is that interacting with large language models through an API, rather than typing directly into the query function, and getting individual responses that you can kind of massively scale things up, particularly sort of things like sending documents, extracting information from them, analyzing them in various ways, outputting it in some other format, and analyzing it. So I think that is a really, really exciting development. I mean, there are obviously some risks and problematic parts of that, which we wonder, how much do we need to know, be able to look at that code and understand what's going on? That's an open question, I think. But largely it you can judge it by how successful it is. If the thing that it produces, if it does end up building the pipeline that you want in a way that works and produces the outcomes, I think who really cares if it's not as neat or efficient as it might be. And so that I think opens up new ways of working for people who otherwise would have been limited by the need to be constantly upskilling with whichever is the latest new kind of bit of code that you need to learn. That is as I say, that's one thing. Sort of the coding and what that's going to open up to social scientists, I think, and I think it's probably quite limited at the moment. The sort of people who are experimenting with that probably still seems a little bit way off for a lot of people, but really it isn't. And I think soon enough that's going to be quite widespread, and that will really scale up the sorts of things that we can do.
I think what you said earlier on about sort of having some understanding, I've sort of always kind of think it's analogous to when the calculators were introduced. I reveal my age because this happened whilst I was at school, and there was a big kind of, oh, is this a good idea kind of thing, and I've noticed as time's gone on in the students that I'm sort of working with, even PhD students, they're not necessarily able to understand that the number that they've got out of a calculation is not correct just because it looks wrong, which I just instinctively know that can't be right. Something must be wrong. They just kind of, there's just an automatic belief in it. And this, because they haven't gone through that stage of doing mental arithmetic, which is almost a kind of artifact of a bygone age now. And it's in this kind of category we're in now because you're better able to use LLMs to do coding if you can already code than if you can't, because you kind of understand what the structure should look like. But I do think that we're getting to a stage where it's more like driving a car than it is being a car mechanic. Whereas before it was definitely, you were definitely a mechanic if you were coding. And now you've got to know how to get it to go in the right direction. And I think it will get smoother and smoother as time goes on.
Indeed. And
as more people adopt it as part of their practice.
Yeah, I mean, we don't look at the C+ underlying the Python code, do we? I mean,
no,
so
absolutely
it's just
not.
a development at the next layer of, and we're now at a point where that top layer is just telling it what to do. And as I say, that isn't enough on its own. You do need, I mean, I think you still need to, if you want to run statistical models, you need to understand what the model is and what the data structure is. And although you're in real danger of just producing some junk if you don't know that, but just the mechanics of putting the code together is now much more accessible to social scientists, and I'm looking forward to seeing how that. I mean, it has some kind of other interesting knock-ons, which are like, what do we teach students? We here at LSE in the methodology department, we have courses on basically teaching people how to code in Python and in R and so on, and we're already wondering, how long are we going to be teaching this stuff? We're going to be teaching something along those lines, but it's not going to be, here's how to write a loop, and so that there's some interesting, unintended or hard to predict outcomes as well. But maybe I can sort of give you an actual example of some of the research that this has opened up to me. And this is something I've been working on with Ian Brunton-Smith at the University of Surrey. Ian's a long-standing collaborator of mine. And actually, when I was, as you mentioned, I was at NCRM when I was at Southampton, and part of that research we did some, we wrote a paper, myself and Rebecca Luff, and this was based on coding the methodological content of journal articles. So it was a building on some previous publications where researchers had done this for particular years back, going back to the 1950s, and then updated in the 1980s and 2000. looking at, the proportion of published articles that are theory compared to empirical, and of empirical what are qual and quant, and using surveys. So we particularly looked at surveys, and we there was, I think, 1,500 journal articles downloaded by hand, and hand coded by PhD students. We had a team of 7 PhD students coding these things, and we did a little code of reliability study. We're sort of glad we did that, and yeah, we wrote an article, and it's kind of interesting, and we've got some citations for it. Surveys still going strong. And anyway, when kind of these large language models come along, and I'm thinking, yeah, I'm sure these seem like they could read a journal article and tell you whether it's theory or empirical. So we built a pipeline using Jupyter and Python, and scraping the content of the articles, getting it to code it, and sure enough, we've got the human codes, and we can line them up and see that the LLM does as well as a human, or indeed better in many cases. So actually, as you do in these kinds of situations where you've got no kind of truth value, when if the human says it's an online survey and the LLM says it's a postal survey, the only way to kind of reconcile those is to go and read it. So Ian and I went looking at some of these discordant cases, went and had a look, and actually oftentimes it was the LLM that was wrong, but nearly as often it was the human that was wrong, and that the LLM was getting the right answer. And that kind of makes sense, because if you're the human, you're going to get bored, you're going to get tired, you've got an incentive to be quick because you're going to get more money the quicker you get through them, and LLMs don't have those incentives. And so we were able to code the full set of 1,500 articles, and this had taken the humans I think it took over 3 months to get done, because of course the humans can't do it all in one go. They need to take a break and go through, and the LLM did this in under 10 hours, and in effect it was free. It cost NCRM, I think, £10,000 to pay the researchers. The LLM did it for free in 10 hours. And of course what we were then able to do is, having demonstrated that this works as well or better than a human, we can then scale that up almost free. Of course, you start paying for tokens and so on, and depending on what kind of a model you want to use, maybe a reasoning model is a bit more accurate, a bit slower, and so on. But then you can code tens of thousands of journal articles, and do it extremely quickly, analyze the data. So that's a project I've been working on, which is using these kinds of this sort of vibe coding and the kind of text classification abilities of LLMs.
Yeah, I mean, I think that's sort of what I kind of loosely call qualitative analytics at scale. I think is one of the things that gets opened up by these new approaches. It's always been a kind of issue for quali researchers, that it's difficult to get sufficient quantity of data to sort of make generalizable conclusions, and that's kind of been the constraint they've been working with. But this is a kind of set of tools which now open up that possibility. There's caveats on that, obviously, and I suspect if we had a qualitative researcher in the room, they would have something to say about that. But it certainly presents new opportunities that just simply weren't there before. Yeah.
And as I say, that's sort of what, once you figure out how to interact with an LLM through the API, so that you can just send up very, very quick repeated requests and dump down the responses into a CSV file or something, and analyze that. Again, it kind of like, it really transforms the sorts of things that you can do, and that you can even think about doing. You wouldn't even think about it because there's no way you could do that. So that's one area. Another area where I have actually an ESRC grant with my colleague here, Tom Robinson and Caroline Roberts at University of Lausanne, and that's part of the Survey Futures program. And what we're doing there is looking at how generative AI can be integrated into survey research, into the sort of survey workflow. Obviously, there's a huge amount of interest in the world of survey methodology about what LLMs are going to be able to do. In fact, I'm going out to St. Louis in a couple of weeks for the American Association of Public Opinion Research APOR conference. I go there most years. I think last year there may have been 4 or 5 papers on LLMs. Looking at the program, I'd say that's probably about 30 or 40% this year.
Right.
It's almost a conference on LLMs in survey research. So it's just a sort of an indication of I think the kind of excitement about the potential here. We're looking at a relatively narrow part of this, which we think will be, where LLMs are very well suited, and that's as kind of interviewers, or indeed as respondents. So we've got a few bits of work packages in the jargon. The first of which I'll tell you a little bit about, which is coding occupation in surveys. This is a notoriously challenging thing to measure in a survey, because what you're trying to ultimately measure, as you'll know this, but the Office for National Statistics or any other NSI will have a very long list of all the occupations that there are in an economy, and this will run into hundreds or even thousands of different occupations, and they're all described. Not all, but many of them are described in quite technical ways, which wouldn't be familiar with the person who does that occupation. Okay, so these two features, the very, very large number of them, and the technical way they're described, means that we can't do the usual thing, which is here's a list, pick your one, or we can't even do that very well with a dynamic list where you type in or something like that. It just doesn't work. So the way that we've always measured occupation is to ask people to give open responses about their job and what they do in their job and the industry and so on. And so this is quite inefficient, because it means that you have to ask every respondent a whole bunch of questions, and for many of them you wouldn't need all of those questions to do the coding. So that the interviewer, or in a self-completion survey, the respondent gives these answers, and they're coded at a separate stage in the office, and there's a team of humans whose job is to find the right kind of 4-digit code given these responses. So it's labor intensive, slow. So what we're doing is thinking, well, we could use an LLM here and integrate the measurement and the coding kind of on the fly. So we built a pipeline that has the LLM as part of the questionnaire scripting software. So if you're my respondent, the first question would be, what's your job title? You say professor. That response then gets passed to the LLM. I won't go into the full detail in it. There's a RAG model in there as well. But in effect, the LLM tries to code it to the 400 list. We give it some information about how to do this in the prompt. It tries to find the right one. Often it can do that. It's pretty accurate. It can find the right code. So that's it. You don't need to answer any more questions. But if it can't, or it can't do that with confidence, then it comes back and it's going to probe you, just like an interviewer would, but it's going to probe you to say, okay, so are you a professor in a university or in a research institute or something like that, something which would enable it to kind of break the tie between multiple equally plausible codes. And so this has several benefits. As I said, one is it's going to reduce respondent burden. These are particularly burdensome questions. Respondents don't enjoy putting them in because they have to type the open responses. They often do that poorly. They don't give very much detail. So it will reduce burden. We get better accuracy with the codings. That what we're looking at thus far suggests that they're going to be more accurate. But also you can then target the follow-up questions, so that and that might be sometimes because the person has given just a bad answer. They've typed in a typo in there, so it could come back and say, could you say that again, or could you give bit of detail about what your company does, that sort of thing.
Mm-hmm.
And we've built this. We're going to be kind of like trying this out on real humans in a survey, hopefully towards the end of the month, and we're going to get some data and write a paper up on that. So I mean, we're aware a number of people in a number of NSIs are working on this, but it has that basic integration of the LLM into the questionnaire opens up lots of interesting possibilities, because you now can start having kind of dynamic self-completion questionnaires. That's one of the, of course, the limitations of moving from an interviewer administered to a self-completion survey. So you don't have the interviewer there to sort of, explain, follow up, ask a probing question tailored to the particular respondent. So we can maybe now start doing kind of more conversational interviewing at scale. What we're specifically interested in our Survey Futures project is, can it be used for cognitive interviewing? The way that we can use this cognitive interviewing technique to evaluate draft questions. That's very widely used in the industry. Involves getting respondents to think out loud when they're answering the question. So we'll present them with a draft question, say, what's going through your mind when you answer? They say, okay, well, I'm a bit confused by what this word means here. Okay, that's a red flag. Okay, this is, and if that comes up in several interviews, then you see it. So we've got a tool that a colleague of ours in the methodology department here at LSE has built. Friedrich Geicher has built a kind of an LLM robot that will interview people qualitatively. So we're going to kind of fine tune this to make it focus on the sorts of ways that cognitive interviewers ask questions and get this data. And we'll see how it works. I mean, I think there's reasons to be skeptical about how well LLMs can act or can replace humans, but we'll see. And then the where it gets a little bit weird is then we're also going to have other LLM robots being respondents. So we'll prompt it to be a particular characteristic of person. Say you're someone who doesn't have a degree, who lives in the north of England, is single and so on, and we get different kind of data from that person than someone we prompt it to be a different kind of demographic. Then obviously one of the things that this enables is this scaling up again. If we can have an LLM as the interviewer interviewing multiple LLMs as the respondent, then the usual kind of restrictions that we put on cognitive interviewing, kind of, I don't know, you maybe do 20 interviews, don't do all the questions. Those aren't because we think that's the best thing to do. It's because it's too time consuming and costly to do more. Particularly if you've got cross-national surveys. We just do 1 or 2 countries. Now, again, these machines can translate on the fly as well. So we could sort of really scale up what we can do in terms of question testing. And I'll just say one more thing about it, is that I think people might object to this. I think reasonably enough, can we really replace human respondents, human interviewers? I think my current take on this, and this may change as we get more into the research, is that probably not. Probably humans are going to be better, but at the moment, many people who, students or people on, with low budgets, research students and so on, can't afford to do it at all. So this might be something that would be available that would give you a good kind of take on where the problems are in your draft questionnaire. Isn't necessarily the gold standard, but is very scalable and in effect free.
Yeah, absolutely. And I mean, that's one of the things that gets us back to the kind of almost the driving kind of analogy, where you've still got to keep your eye on the road. But yeah, absolutely. You can use this to help you with drafts and kind of move you in a better space. And then you go to the humans, and then that's that premium time that you're now using to kind of really refine it. So you hopefully end up with something that is better than if you do either of the things, but not both of them. I did actually, just touching on something which is of kind of interest to me with a slightly different hat on, which is about augmentation. And you can think about the possibility that genuine respondents to surveys might actually start to use AI to help them to respond to surveys. I can't remember what my income is, but my AI assistant knows. And so, you can kind of think, well, what point is that something different that's actually responding to your survey? And what is a data unit in the context of AI augmented humanity? I want to just finish off now with a topic which I think you probably also kind of have some sort of side interest in, I would imagine, given your focus on public opinion. Is often in the news these days as well, is the impact of AI on public opinion affecting elections and something. Do you have a kind of view on the way that's going?
Do you mean, well, there's different ways you could interpret that. I suppose one is, and coming back to the point you made a moment ago about people using AI LLMs to respond to surveys. I think this is a real challenge for the survey industry. There's always been bots that people use it, but whenever you're giving financial incentives for people to complete surveys or do any task, there's always an incentive for the people to automate that and get the incentive without the actual work of being a human. And so the whole industry that's based on people opting in, choose, I'll do surveys for you, I'll sign up to your panel, I'll click on this thing and I'll get some benefit from it. There's a huge challenge how they're going to prevent LLMs basically cannibalizing their panels and so on. It's already a very large concern. I have colleagues who are this is another for another talk, but getting humans to interact with bots and bots with each other and seeing how they all get on and so on. But a lot of them, when they're getting their bots to interact with humans on these panels, what they're actually concerned is these aren't humans anyway. They're actually someone else's LLM here is the person who. So I mean, and there's another interesting consequence of that is that we might see a bit more of a resurgence in the kind of random sampling approach, not so much because of the representativeness, although that's the important part, but because you can build a wall around who your respondents are. You can't just opt into it. You have to be sampled. I've never been sampled for a random probability sample in my working life as a survey researcher. So it's a very low probability event getting sampled for one of these things. So that's another kind of how methodologies might interact in the future. But I think maybe your question was more about misinformation and that sort of thing in terms of influencing people around election time. That it's an interesting question. It's not one that I'm kind of actively researching. There's a huge amount of interest in this topic of detecting information, misinformation, and so on online, how that affects opinion. But a big source of concern, but not one that I'm particularly focused on myself at the moment. I'll let others worry about that.
Yes. And just as an amusing anecdote in response to your never being sampled, I actually got sampled 2 years consecutively for the Labour Force survey at different addresses, which is about equivalent to winning the lottery, I think, in terms of probability.
Yes, indeed.
I've used up all my lottery luck for my lifetime. Okay, well, thank you very much, Patrick. That was a really interesting conversation, and I think our viewers will be also very interested in it. So I'll say goodbye for now.
Thank you very much. A real pleasure to talk to you.